Welcome to The Explainer. Today, we're unpacking something that is just truly fascinating. Now, at first glance, this might look like a simple, everyday textbook chapter for young learners. You know, a beautifully illustrated story about a girl named Lena. But if you look a little closer, you'll realize it's actually an absolute masterclass in foundational cognitive development. We're going to explore exactly how early concepts of math, spatial reasoning, and literally even environmental ethics are subtly woven right into this narrative.
It really makes you stop and think, doesn't it? How do we first learn to measure the world around us? Because if you think back to your own childhood, you didn't exactly start by, pulling out a tape measure or memorizing complex geometric formulas, right? Early learning relies almost entirely on pure observation. It's all about looking at your environment, noticing the differences, and kind of figuring out where you fit into the physical space. And that is exactly the pedagogical framework this chapter uses to teach. So, here's our lesson plan for the day. We'll kick things off with relative height, move right into spatial relationships, examine some real-world extremes, touch on volume and ethics, and then wrap the whole thing up with some hands-on application. Okay, let's dive right into this. Lesson 1, relative height in families. Take a look at this illustration of Lena's extended family get-together. The text tells us she stays in a village with her grandparents, parents, and brother, with some extended family nearby. But I want you to look really closely at the center of this picture. See Lena standing there on that little pink stool? Well, the text actually notes she's doing this because she likes to be tall. It's such a charming little detail, but it immediately introduces this idea of height modification and comparative scale to the kids. And from just that single image, the textbook challenges the learner with these highly specific visual puzzles. It asks them to find and tick the tallest member of the family and to draw a cap on the shortest member. But here is where it gets really clever. It asks, who is taller than Lena's mother but shorter than Lena's father? I mean, wow. This is teaching relative measurement without using a single number. It's essentially introducing algebraic logic, finding x that sits between y and z, and doing it using only the visual observation of a family portrait. Now, after establishing these concepts in Lena's fictional world, the curriculum does this brilliant pivot directly into the child's real-world environment. It asks them, who is the tallest child in your class, and how many children in your classroom are taller than you? This is a real game changer because it transforms the passive act of reading into this active, interactive observation of their own surroundings, completely cementing the concept of relative height. Moving right along to Lesson 2, Understanding Spatial Relationships. Let's look at how kids understand space. So, looking at this sprawling, vibrant map of Lena's village, the student is tasked with another visual puzzle. They have to look past the snowy mountains, the little yellow school bus, and those winding roads to actively locate Lena's specific hut-shaped house. It's an absolutely fantastic exercise in visual processing and orientation. And once they actually locate the house, the book introduces these core spatial terms, nearest and farthest. It asks the reader to circle whether Lena's house is nearest to or farthest from the shop and nearest to or farthest from the school. By using the shop and the school as these visual anchors, the textbook is subtly teaching comparative distance. And again, no measuring tape required here, just logical observation of the physical space that's presented right in front of them. Next up, Lesson 3, Real-World Extremes. We are scaling things up. Suddenly, the scope shifts dramatically from this tiny village to a literal global wonder. We are introduced to this massive monument, the Statue of Unity in Gujarat, India. And visually, it's presented towering over these green hills and literally touching the clouds, deliberately contextualizing the absolute extremes of scale. So the crucial point here is that it highlights this as the #1 tallest statue in the entire world. Think about the massive cognitive leap the book just guided the reader through. We started by comparing the height of a mom and a dad in a living room, right? And now we are scaling that exact same comparative logic all the way up to appreciate the largest human-made structures on Earth. It's just a brilliant expansion of the whole concept of measurement. All right, moving into Lesson 4, Volume and Resource Conservation. Now, the book prompts teachers to ask children how many glasses of water they drink in a day, which introduces the idea of liquid volume. But then it throws a bit of a curveball and asks this specific question: what would you do if water is left in the glass? Should it be thrown away? By posing this directly to the audience, the curriculum is building real-world problem-solving skills and genuine ethical awareness right alongside mathematical reasoning. The text then lists out these incredibly practical daily solutions.
to sensitize young learners about water getting wasted. Things like giving the leftover water to plants, closing the tap when it's not in use, and finding creative ways to reuse water. It seamlessly takes this abstract mathematical concept of volume, how much liquid is in a container, and turns it into a vital lesson on environmental stewardship and resource conservation.
Finally, we arrive at Lesson 5, turning concepts into action. This is the hands-on application phase.
The procedural steps laid out here are highly tactile. First, there's a discussion on why taking water in a bucket for bathing is better than a running shower, which again reinforces both volume and conservation. Then, it has them tearing and pasting colorful paper strips to make different sizes, short and long. And finally, gathering bottles, bowls, and glasses to literally see how many smaller containers it takes to fill a larger one. This physically demonstrates which containers hold more water. Getting your hands dirty with tactile learning like this absolutely solidifies these abstract ideas. And this just brilliantly illustrates the practical application of these measurements. In that paper strip exercise we just talked about, the text explicitly points out that shorter things are generally easier to carry, while longer things are difficult to carry. It even asks the kids to list items that fit into these categories. So the source is actually correlating the dimensional length of an object with its practical weight and real-world maneuverability. Honestly, it's an incredibly practical way to introduce basic physics and geometry. By starting with a simple family portrait and ending up with complex ideas about volume, scale, and environmental responsibility, this source provides a literal masterclass in learning. So I'm going to leave you with this thought. How can hands-on observation continue to reshape our understanding of the world at any age? Because the truth is, whether we're learning about a fictional family or analyzing super complex data, grounding our understanding in pure observation and physical reality is a tool we absolutely never outgrow. Thanks so much for joining me on this deep dive in the Explainer.